Single responsibility principle. It states that a class or a method should be responsible for one and only one thing and should have only one reason to change. Consider you're making a driving simulator. You'd have a class to represent a car that looks like this. A car is responsible for moving and steering itself, so this class follows the single responsibility principle. But then you decide to add a car washing feature to your game, and how about a repair feature as well? We can simply add these functions to the car class. But is washing and repairing itself the responsibility of the car? No. A mechanic should be responsible for repairs and a car wash for the washing. Of course, implementing it like this would still work, but the car class now has more reasons to change and more responsibilities than it actually needs to perform. We can change the car class in cases where we want to update its own driving and steering logic, but also how a mechanic repairs it or how a car wash washes it. This also muddies up the understanding in a collaborative environment. Suppose you made a change to the repair logic and pushed it to a remote repository. For someone else looking at the changelog, it is not immediately clear if the car's functionality is changed or the repair functionality or even the car wash functionality. A better way would be to extract the repair and car wash functionalities into their own mechanic and car wash classes respectively. Now, responsibilities are clearly defined. A car is responsible for driving and steering, a mechanic is responsible for repairing, and a car wash for washing the car. This also promotes maintainability. Suppose we added another vehicle, a truck. We wanted to have some repair logic that applies to all vehicles, but some custom repair logic for each different type of the vehicle as well. We could have an arrangement like this, where we have a vehicle with the drive and steer logic and the common repair logic, and then the truck and car subclasses that include their custom repair logic for each of them. However, when we need to make a change to the repair logic, we may need to change as many as 3 classes in this case. Instead, extracting the repair responsibility to its own mechanic class allows us to keep all the repair logic in a single place. I chose this example because it is easy to see the divide in responsibilities here. However, because of the vagueness of the term responsibility, it sometimes becomes difficult to identify if a class is responsible for everything it is handling or if it needs to be split up. Take for example a file manager class. It is responsible for reading data from and writing data to files. This looks good. It is a file manager and it is responsible for managing everything to do with a file. But one may argue that these are 2 separate responsibilities, reading and writing, and we could split it into 2 different classes, a reader class and a writer class. So which way is the correct way? Well, both. It depends on what you and your team agree on and what works for you. Writing code is more of an art than a science, and these principles are a guideline, not a rule book. Taking these to an extreme would again result in a code base that is harder to understand and maintain.